Hello and welcome to R&D Mathematics. Today we are going to talk about absolute value equations. So first of all, let's say absolute value of x equal 1. Now before I give you the definition of absolute value, I believe all of you have seen this at some point. If absolute value of x is 1, what is the value of x? So, in simple words, when we say absolute value, we are pretty much extracting the positive part of it. So, in this equation, either x can be 1 or x can be negative 1, right? Now, let me actually give you the definition of absolute value of, let's say, a. Absolute value of a is actually defined like this. So, this is the definition. This is a if, when we put this curly parenthesis, that means we are breaking it up into two or more pieces, more cases. If a is positive, then absolute value of a is just a. For an example here, absolute value of 3 is 3, right? Because 3 is positive. If a is negative, now pause the video and think about this. Okay, if a is negative, it's negative a. Now at first, if you have not seen this at first, it may be a little complicated, but let's see an example. In mathematics, sometimes the best way is to look at examples. Negative 3, absolute value of negative 3 is 3, right? We know that, but how do we know? I mean, this 3 is actually negative 3. So right here, a itself is negative. Because of that, negative a is going to be positive. Now it makes sense, right? Next, let's see another way, like, let's say absolute value of x minus 1 equals 3. Now when I say this, there is a geometric meaning. For example, 1, x minus 1, this number 1, forget about minus sign, this number 1, let's say right here 1, and then 3. So this equation, geometric interpretation of this equation is 1, 2, 3. So 2, 3, 4. 1, 2, 3. So 0, negative 1, negative 2. So these 2 points are our solution. So absolute value of x minus 1 equals 3 means we are looking for 3 places away from 1. So in general, absolute value of x minus a equals b means we are looking, if this is point A, we are going b many distance to the left and to the right. Now for example, if you had x plus 1 equals 3, or let's say 2, now what? In this case you have to be careful, you have to rearrange this into x minus 1, right? So the pivoting point is negative 1 now, and 2 places away from negative 1, so negative 0, 1. 1 is one solution, and 2 places to the left, negative 2, negative 3. Let's check. If you put these two into this equation, you must get 2. Let's check. So instead of x, negative 3 plus 1, which is negative 2, and absolute value of that is 2. That's correct. And then this guy, 1 plus 1, which is 2 and absolute value of 2 is see 2. Correct. But when we actually solve for absolute value equations, we cannot draw pictures and do these things. We have to get a little bit technical. Now let's see another example. How about this? 2 minus 3y minus 4 equals 0. Now what? The first and most important step, isolate the absolute value term by simple algebra. For example, don't get confused. So this whole thing, it's like, let's say that whole thing is z, 2z minus 4 equals 0. So 2z equals 4 and z equals 4 over 2, right? You just have to do exact same thing. So 2 times this guy, you add 4 to both sides, so you get that guy equals 4. So you treat that whole thing, that term as one thing, and then 2 times you divide by 2, you get 4, 2, which is 2. Now you have an absolute value equation exactly like before. See? Now at this point, what you need to do, now let me explain this. What you need to do, you don't need to draw pictures. What you need to do, take this inside part, so without absolute value. So this is how we get rid of absolute value. And then equals this value right here. Oh, take that part again, equals negative that. Now that comes from the definition. Remember, absolute value of A equals either A or negative A, right? So we don't know. So depending on that, using that, this is how you break down an absolute value equation. It breaks into two parts. Now it's a simple matter of simplifying. So 3y equals 3y to the right and 3y equals actually 0. So y equals 0, that is one answer. And from here 3y to the right and you get 4. So y equals 4 over 3. These are the two answers. Now let's see some properties of absolute value. First property, absolute value of A is non-negative. It can be 0, but it's never negative. For example, if you see something like this, that's correct. But if you see something like this statement is wrong, right? Sometimes you have to be careful. And next one, absolute value of negative A is same as absolute value of A, right? You can check it with any example, any number. That will always happen because, well, this can be explained with our next property. You know what? Next property, multiplication, absolute value of AB, AB. So you can break it like that. Now using this third one, simply second one can be explained. See, second one, negative absolute value of A. See, negative A is negative 1 into A, right? And it can be broken using third property, negative 1 into negative A. But negative 1 absolute value, we all know that's 1, so that's A. See? And A over B, the division, exactly like multiplication, you can break it up. And let's do one more example. For example, how about this? Quadratic things, quadratic, cubic, anything can appear inside absolute value. Now what? Now what you need to do? The same thing. Don't worry about quadratic, just break it into 2. So 5 minus x squared, you extract that part and you put plus and minus of the given value. Now from the first one I get x squared equal 4, which is nice, x equal plus or minus 2. And the second one I get x squared equal 6, right? And then I get x equal plus or minus square root of 6. So I have 4 solutions in this case: negative 2, negative root 6, positive 2, and positive root 6. I think that's enough examples for absolute value equations. In next video, let's talk about absolute value inequalities, things like this. Okay, guys, thank you.